types of function. One function. This is also known as injection. So, a function f from a to b is known as 1 if under f every element of A has a unique image in B. Underline every element in A. Every element of A should have a unique. What does this mean? So, if this is set A, this is set B, this is A, E, I, O, U, and this is 1, 2, 3, 4, 5, 6, 7. You can see, let's say the function f A is related to 2, E is related to 3, I is related to 4, O to 5, and U to 6. Not necessary. B's every element has to be related to A, but A's every element must have an image in B. When this happens, we say the function, and this happens the function which will relate this from A to B, we will call it as a one function. Understand? Let's take a simple example to understand this more properly. So let me give a question. F from real to real defined as f of equal to 2 minus 3x. Check the injectivity. So, is this function one or not? So, you can see the book will show you different way. I am showing you a very important way to show you. You see, I have taught you lots of graph. Why did I teach you all the graph? Because we will try to judge all this through the help of graph. If you can draw the graph, you can visualize the graph. Believe within 1 or 2 sentences the exam this problem is over. For example, let's take an example. So let me make the axis. So this is a what? This is the equation of a straight line. This is the equation of a straight line with plus 2. This is a y, this is also y. So this is plus 2 is the intercept. That means if this is 1, this is 2, and minus 3. Minus 3 is the, so you can write the equation as like this: y equals to minus 3x plus 2. So 2 being the intercept and minus 3 being the negative slope. So then we can draw the curve like this way. So this curve. Now to check is this one or not, you can imagine to draw a straight line parallel to the x-axis, or if now you can see the straight line meets the curve uniquely. If it meets the curve uniquely at the point, then it is a one function. It's true because you see this point x is this and y is this. Similarly, I can draw one line like this. So this point x is this, y is this. That means what we can say, for every x, what is x? This is x. X is our domain. For every x element of R, there exists y element of the R from the graph. Hence, it is 1 1. Hence, f is 1 1 1. Also note, also the graph is continuous. Now, what does this mean? See, when this set changes, if R changes to natural number, then R changes to some other value. We will see with the numerical what does this mean. Now, let me give you another example. If you do this question, f of x is equals to x square. F is from real to real. Take the injectivity. So if I plot the graph now, so this is x square. Let us make it a little bit difficult. Let us make the question a little bit more. So let me name this x square plus 7. So as 7 is like x square plus 2. X square plus. So let this function. So plus 2 means I've already taught you how does x square curve look like. So in this case, the x square curve will look something like this. So this is 1, this is 2. Okay, if it was minus 2, it would have been here. So now it is plus 2, so the curve passes through like this. Now, if I draw a straight line, what do you see? For every value of y, so for every value of y element of R, there exists how many? There exists x1 comma x2 element of R, right? So every value, so the graph is something like this. So if I draw, so this is x1, this is x2, this is x3, whatever the value, doesn't matter. This is y1, y2, y3. So you can see x1 and x2 we're going to have this, x3 and maybe other one we're going to have this. So that means, what can I say? So for a value of y element of the real of the set R, and x1 x2 is R, there exists x1 x2. Hence the function is not 1 1. Clear? So as I solve more problem, the graph will get more clear. As you plot the graph, it becomes easy. You can always put some values here and check. You can just plug in the values of x here and any value of fx, and you will see, relate them, you will find that it is. Let's take another problem. F of x is equal to 3x minus 2. So, and the function is from real to real. Okay, so domain is real and codomain is real. Okay. So check injectivity. Check the injectivity. So let's see how to do it. Again, what are we going to do? Let's plot the graph. So we know how about the cube graphs. How to draw the cube graphs? If you have seen my video, I have shown you the basic x cube graph. That means f of x equals to x cube. Curve will look like this. It will look like this, right? So here we have an intercept of minus 2. That means, so this is minus 2. So the curve will be going like this. And how fat or how thick is defined by the coefficient of x. If the coefficient is higher, the curve gets thin. That means from here to here it will get thin. Remember this. These things will get thin. If instead of 3 we have 4, it get thin. If it is a 5, it will be even more thin, and so on. Okay. So now check the injectivity. What we should do? We should draw a straight line. So if we draw a straight line, you can see here and here. You can see the curve meets that uniquely. It's really not like x square. It's not meeting at 2 different points. So a value of y, every value of x has a y, right? So we easily say what? We can easily say we can say that for every x element of R there exists what y element of the real set, hence the function 1 1. Clear? That's it. You can see this point unique is this. So this one must be the minus x. This is the minus y. No elements, not a single the range. The range here is also R only, right? So now you can see not a single y is shared by 2. A single y is not an image of 2 elements of R. Hence, clearly say that this function is again 1 1. So you see, you know how to plot the graph. So when we solve the NCERT exercises, I will be solving like this. It will be you will get more and more clear to different functions, because exercises are easy. Rational functions. How what are the rational functions? Rational functions also I have taught you how to draw rational functions. So we will solve that.